So today we're going to be doing a demonstration that involves a calculation. I'm going to leave the calculation up to you to do a prediction, but the reaction we're going to be doing is we're going to be taking copper 2 chloride, which is this, and we're going to be mixing with sodium hydroxide, which is this. So the copper 2 chloride is a clear blue solution, and the sodium hydroxide is a clear colorless solution, and then those are going to react to form copper 2 hydroxide and sodium chloride. Now, if I make it where these things perfectly balance, I will form copper 2 hydroxide, which is an insoluble solid. So you can see that kind of formed, it settled to the bottom there. And then sodium chloride solution, which is the clear colorless layer. If there's excess of the copper 2 chloride, I'll end up with a blue tinge to this clear layer at the top. If there's an excess of the hydroxide, however, I'm going to add phenolphthalein, that's going to make that turn pink, and so I'll end up with a pink color at the top. So to give you a little bit of an idea of what this looks like, we're going to start by taking this one, and currently these are mostly balanced here, so right now it's blue, so we have that hydroxide, but if I add a little bit of NaOH to this, 2 drops there, we'll see that change to pink. Now the pink is going to the pink of the excess of this is going to mix with that solid there. And so we get kind of a purplish color. Let me add one more drop, just to kind of really get that pink color in there. So we'll go ahead and mix that, we get a strong pink color. Mixed with the blue gives us the purple. Then what I can do is I can take that same test tube and I can add one single drop of the copper. And when I do that and I shake it, it goes from the purple back to the blue, which is pretty cool. And I can continue doing that in a 2-to-1 fashion because these two solutions are made of equal concentration. And so since I'm around that balance point, it'll easily change between the pink form and the blue form depending on what currently is in excess. So I'll do it one more time just for fun. Okay, so with that idea, what I've done is I've prepared 2 solutions. This solution here is 8 milliliters of 0.050 molar copper 2 chloride. And this solution here is 10.0 milliliters of 0.06 molar sodium hydroxide. So what I want you to do is I want you to figure out if I combine those two, what will I get? Will I get the pink color or will I get the blue color that looks like this? So if you want to go ahead and pause and you want to go ahead and do that calculation, just to be clear, I'm going to go ahead and put the hydroxide in first. And I'm going to add to that the phenolphthalein so you can see that pink color. Make sure that we're all not playing any tricks here. Okay. And so there's that. And if you want to pause this and do that calculation, but right now I'm going to go ahead and add that 8 milliliters to it. And if you want to make a prediction of pink or blue. Okay, and swirl. And clearly we ended up with the blue. So if we want to look a little bit deeper into what happened there, we can now do some actual calculations. What we really want to do is compare the number of moles of each of these. So to do that, we need to first change these milliliters into liters. 8 milliliters is 0.0080 liters. If I multiply that by my concentration of the copper 2 chloride, 0.050, so molar means moles of my chemical per liter of solution. So if I multiply this by this, then I'll come up with my number of moles. In this case, 0.008 times 0.05, so we're looking at 0.1230 and a 4 moles of copper hydroxide. I'm sorry, copper chloride, copper 2 chloride. And then for the sodium hydroxide, we have 0.010 liters times 0.060 moles per liter. Let's put the actual whole thing there. Moles of NaOH per liter of solution, per 1 liter of solution. So there we come up with 0.00060 moles. And we have more sodium hydroxide than copper 2 chloride, which for some people would mean that we would expect it to be pink. But the reason we don't is because if we look a little deeper into our coefficients here, this 2 here means that we need to have twice as many moles of this chemical and we do not reach that point. So we would need at least 0.00080 moles in order to match this, where neither was in excess, and we had that clear, colorless solution at the top. If I go beyond 0.0080 moles of NaOH, then I would reach that state where we get the pink color, because that would be in excess. But currently, I have more than enough of this. Or if we think of that backwards, we would need 0.00030 moles of this to react with all of this. We have more than that, so therefore we have an excess of the copper chloride, and that's why we saw that blue color. It looked like that.